Hey, Ruchi, good to see you. Welcome on in. Happy Monday. Hope we had a good, hope you enjoyed the earlier stream today with Marcus and the Blocks AI. We did a tutorial, basically a walkthrough of using OpenClaw and adding all the agents in the world into the OpenClaw. So that way it can do everything. Basically an OmniClaw. At that point, it'd be an OmniClaw. Hey, how's it going, Alex? Good to see you. Alex CS is here as well. Good to have you here. Welcome in. Second stream going on. Yeah, we got second stream. We're going to cover the basis, you guys. Hey, how's it going there, Nara? Hey, dude. Good to see you. Welcome on in. Happy Monday. We're going to be doing machine learning introduction today. We're doing lesson 5, where we're doing a thing that someone asked us to do. They said, hey, we need to do random forest. And I've never done it before. So we're going to try it out. I never thought it was good. First like, all right. Thank you, Ruchi. Appreciate it. Thank you very much. I'm excited about this because I've never done random forest before, and we are looking at scikit-learn. So we're going to do some scikit-learn here. We're going to implement the random forest classifier, which is perfect because we're going to find out, would you survive on the Titanic? If you were on the Titanic, would you survive? We've got the data right here. So since we have the data, here's all of our training data. Here's all the example data samples that we have right here. We're going to figure it out. I'm looking forward to this, which is all the passengers on the Titanic. We're going to throw them into a random forest model, and we're going to get a prediction whether you would survive on the Titanic. I'm recording a Raycaster in Rust. Oh, no way! Alex, that sounds exciting. I like me some raycasting. Yeah, some raycasting. Make it look real. Make it look real, Alex. 8 gig of RAM enough for an AI project, or small or mid or high size project can it run? Yes. What type of project can you be? You can basically do all projects except for large language models. And maybe very large, like video generators, text generators, and image generators would be a little bit of a challenge. You could get some image generator, maybe a little bit of a text generator if you do a small language model, right? You could do that. Otherwise, all AI is basically good. So right, this random forest example, even if we did it in a deep learning model, which I would love to do, would be possible on your laptop. You can absolutely do it on your laptop. No problem. No problem whatsoever. So we're going to take all of this data. We've got the passenger survived or not, the class that they were in. They have a name, their gender, their age. I don't know what SibSop is. What is Parch? I don't know what Parch is. There's a ticket, so you could see what, like, maybe floor they were on or something. The fare, how much they spent on the ticket, right? What cabin they're in, so how fancy it was, right? How fancy it was. And then what day they embarked. Wait, isn't that all the C? No, it's something else. I don't know what that is. I don't know. There's an S, a C, and a Q. I don't know what embarked is. Well, we're going to find out. Real, like this is you doing massive project, can run 8 gigabyte RAM? Yeah, absolutely. Absolutely. You should absolutely be able to do that. I mean, I'm doing this on, everything's on my laptop. The only time that you really need an NVIDIA cluster is if you're going to be doing very large language models. When that is, you're doing big gigabytes and gigabytes, right? What is it? Maybe like 100 gigabytes or something? That could be a thing that you would not run on your laptop, right? You wouldn't want to run that on your laptop. I don't think so. That would be fun, but you're not going to do that. Basically, though, this, for example, you could run on your laptop easy because that's what I'm doing right now. That's exactly what I'm doing. Here we go. Okay, so let's get into it. Let's get into this. Okay, so we're gonna take our lesson 7 and we're going to convert it into a lesson 8. And our lesson is going to be using scikit-learn. Me with 2 gigabytes VRAM NVIDIA M450X. Hey, you can do a lot with 2 gigabytes. You can. You really can. That's a lot. Absolutely. You sure could. Yeah. I know it sounds like it's small compared to what we are spending on these super big clusters. The good news is you really can get a lot, though. All right, so let's do this. So we're going to CP lesson 7, and we're going to lesson 8. We'll do lesson 8 here. 08.py, and this is going to be our what do you call it? Random forest. Here we go. Random forest, you guys. Introduction to machine learning. Random forest classifier. There we go. Random forest classifier right there. Hey, Vicky, you're back. All right. Thank you for applying on LinkedIn. Absolutely. Hey, Derek, check link share. I put something there. Did ya, Derek? All right, let's take a look, you guys. Link share. Here we go. Derek. Oh yeah, I saw this. Visit. Yes. You did this. Check the look. So you built this? Did you build this? It says Dina. It says Dina right here. DNA. All right. So what do you got? You've got your safe tensors, which is 612 megabytes right there. Like, very nice. You did. All right. Good to hear it. Good to hear it. You're noting down that what type of AI projects you run in 8 gig of RAM plus 2 gig of RAM. Yeah, I mean, you could basically it covers everything. You could do everything, even this right here, I think, right? Hey, Derek, it's an ASR model. Would Root be able to run this ASR model? Transcribes Ghanaian languages. Nice. It transcribes them. Check the model card. Model card. Here we go. There, much better. Let's zoom in. All right. Would Root be able to run your model with Root with 8 gigs of RAM and 2 gigs of VRAM? Is that possible? Yeah, he can run it even on CPU. See? Root right there. See? Yeah, right? You can absolutely run it. All right. Greedo Nano is a 153 million parameter multilingual conformer CTC model for Akan, Degbani, Ewe, Ghanaian English, and Ga. All right. A lot of language there. It takes 300 megabytes of RAM. All right. See? It's a really good model, and you can get 300. You can do it. Absolutely. Hey, yo, new here. Yo, Rajendra, welcome on in. Good to have you here. Happy Monday. We're a coding channel. We're currently looking through Derek's code. What's your name? Oh, you guys, thank you for asking. My name is Stephen Blum, CTO at PubNub. We are an API community, API communications provider. So if you've ever built anything with multiplayer games or sports and media, right, you've maybe used my technology. You might have. Telemedicine, things like that. Hey, NB60, good to see you. Welcome on in. Good to have you guys here. Yeah. Hooray, 2 streams in a day. Yes, AW9. Yep, we did our morning stream with our guest speaker, Marcus Kohler, developer relations engineer at PubNub. Now we're jumping back, and it was a request. Someone was asking us to do this. We need to do a random forest classifier. And so that's what we're going to do. We're going to find out whether you would survive Titanic. We're going to find out. We're going to have the data. We have the data for it. How you have custom live captions like this right here. Custom live captions. Well, thank you for asking. I've got that window open because it's a frequently asked question. Wait, is it here? Yeah. So you see I've got all these subtitles. Thank you for the hearts, you guys. Appreciate it. Yeah, so these subtitles right here. Open source project I created 8 years ago. There you go, 8 years ago now. Wow, we are old, you guys. We're old. And now we're using it on live YouTube. We're using it on YouTube. That project idea, random forest. Yes, is that the project idea? It is. So we are going to take our random forest classifier. We're going to go our linear regression classifier. And we're going to change it to a random forest. So this is from yesterday. We're going to convert this into a random forest classifier. We're going to use scikit-learn. What is liniface? I don't know. What is liniface? Tell me about it. I asked the same question yesterday, Vicky. Yeah, almost at number 1. All right, you're making our way. Keep going. Good to have you guys here. Yeah, so this is available for free, permanent, free forever. Let me make sure this is here. Yep, so YouTube, Twitch, subtitles, and it's all you have to do is follow these easy instructions. It's just a few instructions. You copy and paste a few things and you're good to go. And if you want different styles, right, there's different styles here. So you can do rainbow, you could do, NanCat, which I like. I think NanCat's great. It's this, you did it, it's that, it's the ASCII art. It's the ASCII art that did it. 60, it's the ASCII art. Yep. And if you want one word at the time, the way I have it here, right here. You can use this configuration. Finally, some good project. Thanks, Steven. Yeah, I'll try to best contribute. Sounds good to me. All right. Yep. So we do have our GitHub. We do have this on our GitHub right now. We are going to convert this into a random forest, which I've never done before. I've heard about it, and I always thought it sounded really neat. We're going to try it out today, you guys. We're going to try it out. I'm really looking forward to it. I'm looking forward to it, you guys. So this is going to become a random forest is what we're going to do. So we're changing it to random forest. So let's relabel this. All right. Is it this face? It's that face right there. It's that 160, MB360. It is that one. It is. It has to be. There's no other face that it could be. You also completed Pokemon 1, 2, 3, and now on S4, 15% completed. That's a lot of Pokemon. Season 1 through 3 completed on Season 4. Ruchi, that is a milestone right there. That is a milestone. You got it. Very nice. That's great. So we're going to do the random forest classifier today, you guys, because it was requested. Nitrogen monoxide. That is a gas, right? Nitrogen is fine. But what about the monoxide part? Because we breathe nitrogen on a regular basis. I don't know about the monoxide part. That sounds like it could be a problem. Maybe a little bit. All right. Yep, that is the alphabet right there. You just typed it in. You paste all of it. Alphanumeric. That is alphanumeric. What a great... Have you guys seen Adventure Time? Remember alphanumeric used to be a thing? What you doing? Hey, Deb. Hey, Deb Eloper. Welcome on in. Happy Monday. We are going to be doing Introduction to Machine Learning today, and today is a random forest classifier. Random forest classifier today. All the different letters. Hey, alphanumeric. Do you guys remember that? Alphanumeric. How do you see it? Alphanumeric. I love that. I love it. Rich repo? Let's find out. So let's go to our Discord really quick. Go to link share. And it should be around here somewhere from yesterday because we posted it yesterday. Here, let's scroll around here to it. Where is it? I know it would be here. No, not that one. Not that one. You know, I'll paste it again. I'll put it in again. I know we have it around here somewhere. I know we do. Here it is right here. I'm going to reopen it. Here, this is it right here. So we're currently at lesson 7. We're converting lesson 7 into lesson 8. So we're going to take the linear regression that we built yesterday and convert it to a random forest classifier. Thanks for such a huge welcome. Hey, all right. You're from Pakistan. Hey, excellent. Developer, good to have you here. Thank you. Thank you. All right, here I'm going to repaste this into our link share really quick. Let's go to the pasting. There you go. This is where we're at. So we're going to convert this file here into a random forest, which is what we're doing over here. So this is where we're at right now. Random forest. And we have to do a lot of things because we need to read up on random forest. We've never done this before. This is going to be a new thing for me, you guys. This is new. So we need to install scikit-learn. So let's see, pip install scikit-learn. Is there an easy pip? Yes. Okay, let's make sure we got this library. Okay. We open up a new window, pip install scikit-learn. There we go. What's your country? United States. USA, Seattle, Washington. There we go. I spell it, yeah. Washington. There we go. Washington right there. All right. All right, you guys. That's a lesson, not a group project. Or am I missing something? Oh, you know what? If you want to contribute, feel free. Feel free because I'm learning as well on this one. This is something new to me. It's something brand new. Brand new to me. And tomorrow we are doing a group project though. If you are excited about this, if you go over to our Discord, there is a thread called Real-Time Group Project right here. We're going to be doing it's YouTube clone. And we're going to have a Python server backend, which I'll be starting tomorrow. And then we also have like a React front end, I think something like that. What are your expertise in tech field? All right, developer, thanks for asking. My name is Stephen Blum, co-founder, CTO at PubNub. Todd Green is my co-founder. We started this company over a decade ago. It is a distributed communications platform. Distributed. So we distribute all of our code in containers across all of the EKS clusters and Amazon's data centers. And we have over 1 billion devices connected, like these guys, like 1 billion devices. So things like order food delivery, IoT, gaming, lots of things. So what level of cloning are we talking about? Probably just the basic video streaming is what I'm thinking. Basic video streaming to get started. Oh no, you're third. Oh no! So yeah, so if you ordered food from Swiggy or ordered any tickets on Ticketmaster or watched any TV sports with DAZN, you've used our technology and you didn't even know it this whole time, right? Isn't that great? So let's see. Oh, Kaggle. Yes, Kaggle have free data set to training model. Can you check out? I hope they're still available free. It's free. Yeah, I think so. Completely free. Kaggle makes it possible. Absolutely. All right, let's make sure we got all our requirements. Okay. So we're going to have to do something different here. We do want pandas for reading the CVS. That's all pandas. Do you guys use pandas for anything? Did you know the only thing we use pandas for is loading CSV files and putting into data frames? Well, nice, great. Oh yeah, thank you, developer. A great suggest me, which I choose in my career, a fresher of, okay. I recommend AI topics. I think it's challenging, right? AI topics challenging, and it helps you learn a lot along the way. It helps you learn a lot. You have MongoDB and Ada Lab. Oh, exam. Oh, okay. Tomorrow after any help? Yeah. So MongoDB is in your test. I remember when MongoDB came out and it was a disaster. It was called web scale, which means it didn't work, right? We were taunting it. Web scale meant big and powerful. It was not web scale. It barely worked. It barely worked. It was neat though. I'm so shocked to see that it's on your test. Can I start live stream for learning Python in 0 stage so this can be growth? Yes, also some earnings. I mean, you give it a try, Ruchi. Give it a try. Make it your dream. Make it happen. Make it happen. All right, we're doing some heater here. We are doing a little bit of heater. I'll keep heater there. Do we use NumPy? We do. So we're going to be doing different things now. Our training needs to be different. We need to do a lot of different things. Okay. That's what we got to do. A lot of different dreams. Okay. All right. Sounds good. 60. I see what you're saying over there. We have to do it in command shell. Bro, wait, what are you saying over there? Yeah, we're using the terminal window. We like our terminal window. Our terminal window makes us happy. We love it. We love it here. This is the best place in the world. I love it. All right. So we're going to have to rip all of this apart. This whole thing needs to become to different. What does heater do? Heater is a plot. So it's a heater plot. Heater, here, I'll show you. Watch this. Google heater plot PyPy. PyPy. What do you do? Heater plot PyPy. And this brings up, I'm actually getting serious. Look at this. All right. Heater plot PyPy, a PyTorch and NumPy visualizer tailored for 1D and vectors and 2D matrix. Yes. And in fact, wait, is this it? No, that's not heater. That's not heater plot. Oh, it got it wrong. Wait, did I click on the right one? Here. I'll scroll to it. Here. This is the right one right here. Heater plot is a matrix visualizer. You're the best. Yeah. Answer me, bro. Oh, developer. Sorry, I missed your message. What'd you say? Is it day at US, but it's night in Pakistan? Yes, it is currently 12 p.m. in the afternoon. It is 12 p.m. Oh, hey, 60. Hey, all good here. I see your messages. I see what you're saying. Wow, yeah, it's pretty early. It's pretty early here. Oh, it's afternoon, right? It's just afternoon now. So yeah, so this is heater plot. Gotcha. Nice. All right. So let's keep on going, you guys. It's 12. Oh, it's exactly 12 hours ahead. Whoa, no way. We're exactly 12 hours apart. Opposite sides, you guys. Opposite sides. Freeform tomorrow, starting first live. Done. All right, sounds good, Ruchi. Please come. I'll try. It's if I have a chance to. You aren't looking at my message yet? I see it. I see you. I see what you're saying. I'm just not I'm not reading it out loud. I said, you aren't looking at my message is what you're saying. What is this language? It looks like English? It looks like English. Coding isn't for you. Oh no! Coding is great! You're really smart. Oh, work really, really hard. Amazing. Well, thank you. That's really nice to say. Appreciate it. All right, let's get our next song going here, you guys. Here we go. Here we go. Let's get into it. All right. All right, you guys. So now what we need to do here is we need to convert our linear regression into a random forest. Random forest classifier. I'm not typing Greek. Okay. All right, sounds good. All right. You told me about dunder methods. Yeah, have you made a video about it? I sure have. I sure have. Yes is the answer. Is it released yet? Let's find out. Let's find out. Here we go. See. All right. Google. Stephen Blum. YouTube. Dunder methods. Python. See if that's available. Oh hey. Oh hey. What do I see right there? Look at that right there. Python basics dunder magic methods. Right there. Hey, we've done it. Right there. Big thanks, Richie. Yeah, absolutely. Absolutely. Hey, Stephen, morning. How's it going there, Parth? Good to see you. Welcome on in. Happy Monday. Thank you, mate. See you. Sounds good, DRK. Thank you for hanging out with us. All right, so we're going to have to rip this apart here. So we need a new init. We need a new initializer. We need a new trainer. So we're going to have to do this. We have to do this. We don't need gradients anymore. We don't need the optimizer. We probably should have a predictor, but I don't know what it's going to be. I don't know how to do this yet. And we're going to have like a model that deals with it. So return true. All right. Well, we have to rewrite this. Pass. We probably don't need this anymore. We could use this, but I don't know what it's going to be for. So I'm just going to say pass for now. This is a dunder method, by the way. Or right here. Dunder method right there. So, and then we get a loader data, which this part looks correct. I think we're good here. I think we're good on this side of the thing. We probably should add more features and things like that. So currently we have age, genders. Let's see, what else should we add in here? Yeah, let's see if we can load more data. All right, so we've got survived. Here we go. That would be the targets. Now let's see here. We could also add in the fares, right? So we should add the fares. I think that would be a good one. Bye, pal. All right, sounds good, Ruchi. See you then. See you then. Okay, so let's do fares, you guys. We'll do fares. And this will be fair. Wait, we don't need this. We just need fares. Fair for fair. Is it a fair? Yeah, fair. There we go. I think that'll do that. I think that'll do good here. So let's see. For fair in fares. There we go. Perfect. And then we are going to grab this. We say fares. All right. So that gives us 3 data points. What else can we grab from this? Do you guys want more? I think we should grab more. I don't know what sib is. Age was good. Name, probably not. We don't need. We could do P class. We could do P class. Although, does that really? Do you really know? What I would prefer, if we're going to ask ourselves this question, and we're going to say, "Hey, would I survive on the Titanic? Would I have this information for myself?" Right? So there's a lot of pieces of information here. There's a parch, there's a ticket, there's a fare, there's a cabin, there's an embark, which I don't know what that is. And I don't know what a P class is. So I wouldn't know how would you answer that question? Oh, you want to be first? 60? You want to be first? Well, you're on your way. I mean, you're really close. You're really close. Keep going, keep going. Don't give up. Live your dreams. Follow your dreams. You can do it. All right. Ages, genders, and then survived or not survived. Okay, looks good. Good old ML model training montage. Yeah, there we go. Oh, man. Yeah. All right, let's keep going here. So I think we've got age, genders, fairs. I do like the idea of adding fairs. I just don't know what specifically you would answer that if we're going to ask the rest question. The best. You got it. Okay. So how are we going to do this? I think fair is good. I don't think we need to go anymore. We got age, gender, fair. I guess we could do class. And then also for the fair, we need to know what the max fair is. So what is the max fair? Max fair equals, what is max fair here? I see 70, 18, 21. Those fares, 82, 676. Okay. So they look like they're pretty small fares. Really small fares. Really good deal for a cruise, right? Really good deal for a cruise. And there's some empty fares. Uh-oh, you guys. Do we really? Or no, is this a fare? 263? Ooh, that's a big one. That's a big one. Oh, the QWERTY. We got the QWERTY over there from 60. Okay, so I think maybe over 400 is a good number. Maybe we could do over max fare is 400, yeah? So I'm seeing, we could math this out. We could find it. We really could. We could. You have to leave today with all those fares? There's so many fares, right? So like, this one is weird because it's a fraction of a penny. You can't have fractions of pennies. So that's just very odd. Let me double check this is the correct thing, right? Embark, cabin, and fare. Yeah, it's the third final item. It's the third final item. So let's say like over 200, maybe 300. I saw a pretty big one in there. Here we go. So we'll just say 250, right? And then we will divide this. Here we go. Divide by max fare. There we go, max fare. I think that does the trick right there. Looking good. Liked and subscribe. Hey, very nice 60. Thank you. Hey, Quick Fix, good to see you. Are you excited for tomorrow? We're going to start with some Python backend server. And Quick Fix, are you going to start on the front end? And how should we collaborate? What's your favorite approach? I guess obviously we could use Discord and things like that. So let's keep going, you guys. Where's my leaderboard? I don't know what happened. Where'd it go? Where'd your leaderboard go? Where are you on the leaderboard? Oh, my leaderboard's gone too. It's empty. It's empty. What happened? Where did it go? I have to reload that now. I have to reload it. What happened? Where did it go? You're number one here. Hey, Parth. Hey, right there. All right. Number one. Yep, you are number one. Right there. Very nice, Parth. Good job. You win. You win. Let's see if we can visualize some of this data that we're loading here, yeah? Let's make sure we're good. You're number 4 now. What camera do you use? Like, dope, thank you. This is the Sony A7 II. Sony A7 II. So it's old. It's like 15-year-old camera. Wow, what a good camera. It's that old? Yeah, it's really old. But it still works well. It still works very well, you guys. All right. Very good camera. Let's see here. Okay, let's see. Scroll things. Looking good. Okay. Music's very annoying. All right, we'll go to the next song. How about that? How about we get rid of this one? Let's get rid of this one, okay? 1 second, you guys. We're going to get rid of the song. Do I like this one? Yeah, I'm going to get rid of it. There you go. Is that better? I don't know. I don't know if that's any better. Let me know if that's better. Here, I can lower the volume there. There we go. All right. Okay. So, yeah, I know. Old camera, right? Does good job. Max age, max fare. We've got our genders, our ages, and the fare. How much did you pay to get on the Titanic, right? How much did you pay? Okay. So let's see here. All right. So would you survive on the Titanic? Is the question. And then we're going to pin that message. There we go. That's what we're going to find out. We're going to find out if that's the case or not. Okay. So we've got all of our Titanic data here. I'd love to run this and see that it's working properly. So let's see if we can load this. So we don't have a linear regression model anymore. This is going to be our random forest model. And I don't know what our inputs are going to be. So we're just going to keep it blank for now. And we do know what our output is. Let's see here. Let's take a look. Okay. So max death, random state shuffle. We don't need to worry about those things. Okay. And then we have a predict. What is CLF? Oh, this is the classifier. Okay. We've got our classifier. We got our X and Y's. All right, that's pretty straightforward. We can do that. How's it going there, Garcia? Welcome on in. Good to have you here. Happy Monday. Thank you for joining in. We're doing random forest classifier with introduction to machine learning today. Let's see. Let's put this on a new line. Introduction to machine learning, random forest classifier. Never done it before. Have no idea if we're going to do. I mean, we'll know what the answers are. Once we get the data out of this, we'll know what the answers are. So let's import from scikit-learn here. Let's do this. Here we go. So we're going to get this random forest classifier. You just want to listen to you as well. Focus on your notes. For my opinion, the music has no role at the end of this programming stream. I see what you're saying there. Yeah, I do like it. I do like to have the music on. We also did a poll, and I was actually really surprised. We did a poll last stream. A lot of people voted, and it was perfectly down the middle. It was down the middle. They're like, hey, should we have music or no music? And it was like perfectly down the middle. So I have to do a tie. The Titanic dataset brings back some memories, does it? Whoa. When do you learn about deep learning and machine learning? Oh, when did I? About, 12 years ago? Yeah, about 12 years ago in 2014. 2014. That was about the year that I did that. And yeah, it was a lot of fun. And it was before most of the, before PyTorch was a thing. TensorFlow was barely a thing at the time. Keras was not even connected to TensorFlow. It was a separate thing. And I was learning all of this back then. We start from dataset one way or another. In machine learning, you got to start from the dataset. You sure do. Been a year since you coded in reinforcement learning. It a bit rusty now. Hey, you know what? It comes back quick. What is the difference between GPU and TPU? Oh, they're very similar. So a TPU has, GPU and TPU both have separate core clusters, right? So in a CPU, for example, you might have 8 to 16 to 32 cores. You can even get really big GPUs or CPUs that go up to like 100 cores. Well, a GPU and a TPU have much smaller cores, but they're general purpose. So they can do like basic math operations, and there's a lot more of them, right? So there's a lot more of the transistors dedicated to general purpose. TPU, GPU are basically the same. The TPU is going to be more focused on just matrix multiplications and custom kernels, where the GPU has other kinds of math that it's like more capable, but it's like not as application specific. So TPU is going to be faster and more energy efficient. 2014 year. Oh, wow, Alex, no way. Yep, we're aging, you guys. We're aging. You were already a math genius before learning machine learning. I mean, I wouldn't say that. I wouldn't quite say that, but thank you for mentioning it, Garcia. That's very nice to say. A lot more is an understatement. Hey, user, you're welcome. Absolutely. All right, so let's keep going here. So we have to implement all of this over again. So the good news is this is reusable. So let's load our data. Oh, let's see here. Generate data. We don't need this function anymore because this is random data. We're going to load the data from our data set here. So there we go in our data set. I believe this is good. So let me clear this off, and then let's load our data, and then find out what our features and models look like. And then we even do a heater plot. We might as well. Actually, I don't know if we can do one or not. So let's try this. Let's do Python lesson 08. There we go. It's loading in. It's loading in very slowly. This is unusual. Hey, Rockin' Brain, good to see ya. Welcome on in. Happy Monday. Whoa, we had an issues here. What happened? What did we do? Main line 72, random forest. Oh, well, why is that broken? That should work perfectly fine. We need to get this working. Good to see you, Rockin' Brian. Good to have you here. Do you do EDA on this, or did you have an idea of it already? Well, Mr. Dungwall, good question. Now I need to understand, what is EDA? What is that? What is EDA? What is that? Okay, let's see here. Would you survive the Titanic? Would you survive the Titanic? That's what the question is we're going to answer today. Hey, Gloomy Traffic, good to see you over on YouTube. Welcome on in, welcome back. We're doing your idea, Gloomy Traffic. You're like, hey, could we do a random forest? We're going to try. I've not ever really spent time on random forest before. We're going to implement it. And we're going to see how much more accurate it is with the Titanic data. Ooh, nice. Yeah, thank you for the recommendation. Event-driven architecture. Oh, yeah, I feel like I should know about that. That's kind of my business. I didn't. We don't call it EDA so much. We don't call it EDA. Before training needs, sir. Exploratory data analysis. Oh, see, that's what. Okay, got it. Not that EDA. A different EDA. Okay. See, yeah, event-driven architecture is also a thing. It is. It really is. Exploratory data engineering analysis. Yeah. That's one of the most important parts. When you're doing AI, check this out, you guys. If you're going to be building an AI model, you need to see what the data looks like. And you need to plan out how you're going to encode the data into the model, because that encoding process involves you converting data, classes, and numbers and letters into like floating point numbers. And you have to scale them between 0 and 1 typically, right? All right. Rock and Brian, I know, you know what? I thought your EDA was a good answer. I thought it was. You think you took one hot encoding for a feature? One hot encoding works also. Yeah, you can do that. So you can do one hot encoding or you can do scaling. You can do either, right? So that means converting your classes into a bunch of numbers, right? So one hot encoding is like this. You've got all your classes. So say like a three class item like this. So you've got either, it's like, for example, cat, dog, or bird, right? So say it's a type of animal, right? So it can be one of these things. It probably won't be multiple things. It probably be just one. And so this is one hot encoding right here. You could also do a scale. So you could say, a cat would be 0.33, right? And then maybe a dog would be 0.66. And then a bird would be 0.99, right? So you could do scaling as well to represent the class. Both of these work. One hot is a little bit more obvious. Scaling is more precise, right? The resolution better. Between the two, it's kind of hard for me to tell. It is kind of hard for me to tell. Which AI model do you prefer to help you code and fix errors? I like Codex. I like Anti-Gravity, which is Google. And then I like Claude, of course. So you've got Claude, Anti-Gravity, and Google. And so Codex, Anthropic, or Codex with OpenAI, Anthropic with Claude, and Anti-Gravity with Google. Those are the ones I like. Okay. So let's see if we can run this now correctly without crashing. Syntax warning. Indices must be... Oh, whoops. Yeah, I messed that up. So where's that cat? We don't have any of that anymore. All right. Let's see here. Print model. Return. Looking good. Okay. Loading up. All right. Random force init. Missing required parameters. All right. What does it want? We're going to find out, you guys. It wants none of these. Here we go. Let's get rid of that. Cool. Save. Run. Now it's going to be happy. Oh, come on. Oh, there's no repr. Okay. Return. Empty. Nothing. There we go. There we go. There we go, you guys. All right. So far, so good. So far, so good. You think scaling would be better for less false positives as there is a range? That could actually, Mr. Dungwall, I've had really good results with scaling. I've had really good results. And I really like it. I like it a lot. It helps. And it's also simpler. And it's faster to train. Because it's less features. Because if you're doing a one-hot encoding, it is very obvious which one you're currently working on, right? In terms of what class that you're using. However, there's a lot of zero multiplications involved, and so it's a little bit of a waste, kind of a waste in certain cases. Unless you do like an embedding, you can do an embedding, but then you're using more. And do you really need an embedding for such a small class? Typically, no. Sounds like a good interview question: scaling versus one hot. Yeah, that is a good interview question. It is. Which one would you use? I end up going towards scaling. I do. Thank you for the reactions, guys. Embedding is overkill. Right, I know embedding would be overkill. Yeah, I would. All right, so now that we've got our code up and running, let's see if we can make it. Thank you for the hearts, you guys. Appreciate it. Good to have you here. Thanks so much. Yeah, I see that. I see the floaty heart icons here. So many floaty heart icons. Appreciate you guys. Thank you so much. Okay. All right. So where do we go from here? We need to take our random classifier and initialize it, and use that as our model internal to our random forest classifier class that we're building right now, right? So that's the thing we got to do. That's what we got to do. Thank you guys so much for your actions. Appreciate it. Thank you. Okay. All right. So on our initialization, we're going to say self.model equals, and we're going to create a classifier here like this. Copy and paste that. Okay. We'll close this so we can see what we're doing over here. And then let's see here. You saw a tutorial that teaches the foundations of quantum computing. Ooh, nice. My question is the math required for machine learning the same as the math used in quantum computing? Well, they're different. They're different, right? If you want to find a similar one, which I really like, you want to use quadratic unconstrained binary optimization. Cubo is closest to ML. So take a look at Cubo for quantum computing. Take a look at that. That was the one that resonated with me the most. I identified with Cubo. I really liked it. Things like binary unconstrained, quadratic unconstrained binary optimization. That's what that stands for. At what age is too late to learn machine learning and math? No age is too late. You learn immediately. Eminem, you learn immediately. Don't let anyone stop you from learning new things. Don't let anyone stop you. Quantum computing is way more electrical engineering than computer science. Yeah, from an engineering perspective, as we have gates and things, so here's the thing. This is what I thought was really weird. Check this out. Did you know that quantum computers are just regular computer chips for the most part? They're just ordinary computer chips. And then they do have, I'm not exactly sure specifically what medium they use as the atom. So they can sample each atom and they can link each atom. So I'm not familiar with that process. It's physics. Physics. Okay, got it. It's physics. Gloomy says physics. All right. Excellent. So we've got a random forest classifier. Do we want to do other things? So there are a few other features here that we can do. Thank you for the hearts, you guys. At what point do additional trees stop improving accuracy? Let's find out. So we got the number of trees. Number of decision trees. Here we go. Right? Number of estimators. So let's grab that one in here as well. Thank you for the hearts again. Appreciate it. I can see what you're doing. I see it. Here we go. The chips are silicon. They are silicon. Yeah. So that's the part that I was like, what? No way. Really? That is impressive. Let's see. Get rid of that. Number of estimators equals 100. All right. So we're going to do this. We're going to say to do lower/increase find if better. Find if better. There we go. I like it. Now, what is random state? Let's find out what random state is. Random _ state. Here we go, you guys. Yes, they are. And, yes, silicon chips. Yeah. And there was this one problem they said can't be solved without quantum computing, the optimization problem, right? One company did that with regular computers recently. Ha ha ha! Yeah, that's one of the things. Like all these promises from quantum processors. They're like, we're going to solve the most challenging, difficult problems, which sounds possible because you're using nature to solve nature, right? Nature as in the physical atom. Rather than building a construct of multiple atoms and having a bit on and off, you can use the entire atom in all of its states, which is infinity. Infinity states per atom. It sounds like it's the ultimate nature calculator. All right, doesn't that sound amazing? See the atoms spinning around in your head, and then seeing how they can be quantum entangled, and then what kind of math we can provide if we had an infinite precision calculator. That's what a quantum processor is. Infinite precision. We're gonna have to watch this tomorrow to keep smiling. All right. Sounds good to me, Gloomy. So cool. It's so cool. I was about to go all in on quantum computers, but then I don't see jumping anywhere near, so I'll stick to AI, right? AI solved those problems. That's what it was. We have these quantum processors that are promising the ultimate solutions. And we're solving it already today with regular AI algorithms. Isn't that nice? Quality control only 10 years away for the next 50 years. Yeah. Quantum computing. Grunkle Stanley, hey! Yeah, quantum computing only 10 years away for the next 50 years. You know it. You know it. All right. Controls both randomness and the bootstrapping of the samples used when building trees. As sampling considered when looking at the best split. So max features less than number of features. Okay. All right. We'll figure that out. I don't know if we want this one or not. I don't know. I'm not sure. So we've got a max depth here. And then I would say like, let's make it like 10 or something. I don't know. And then we got number estimators. And we've got number of features. Number of features. All right. Number of features. Wait, actually, wait. What is that called? Features. Do we even... In features. Monotonic CSS, right? Do we have this? Number of features seen during fit. Okay. So we do need to specify this. Here we go. Features. Number of features. Input class, like input classes, basically, right? What did they use? Tensors are quantum gates. What they did is use tensors as quantum gates and then solved it. It was like a mic drop moment. Oh, there you go. Yeah, I mean, it makes sense because you can calculate with AI really beautiful waves. Like, and it's not like infinitely precise, but it's precise enough to where it can solve most things already. It can. And it can be represented in higher levels of dimensions. A lot of dimensionality, you guys. Lots of dimensionality. All right, so let's see if this runs here. We'll try this really quick. Python, lesson 8. There we go. Number of features. We have to actually specify something. There we go. Okay. All right. Why did that fail? It should have been fine. Missing one required parameter, features. Did I type it wrong? Oh, no, I didn't. Here we go. All right, so our number of features is going to... We already know what our features are going to be. It's going to be 3 features, right? Age, gender, and the fair. So that's 3 features. So we're just going to set it to 3. We're just going to say 3. We're going to keep it easy. We're going to keep it super easy, you guys. All right, 3 through 3. Where is that at? Here. 3. Okay. Good to go now. No errors. Okay. Did you mean max features? On what line? Let's see. Unexpected keyword are number of features. Yes, I meant max features probably. I mean, I thought this was it right here. Max features. There it is. Okay. The number of features to consider when looking for the best split. What type of machine learning algorithm are we using? M&M. This is the random forest classifier. It's going to take in a whole bunch of features, and it's going to classify whether you survived on the Titanic or didn't. And we can take your age and your, well, I guess we can't really ask chat what your age is because that is a doxing type thing. So we'll create a list of range, and then you could decide whether you would survive or not. So that's what we'll do. I think that's a good plan for today. All right, so max features was the answer. We don't need to worry about random state. And we're gonna rerun this. No errors? Still errors. Oh. We can fix that. That's not a problem. This is line 69. Here we go. Thank you for the hearts, you guys. Appreciate it. What are our predict? Oh, wait, we don't have a predict function. That's why. I need to return this right here. Right here, you guys. Yo, Show, thank you for the Pi 5. Appreciate it. My gratitudes to you. You're so nice to me. You're so nice. Thank you so much. Appreciate you. Wow. Do you use Clay? Thank you again, Show. Wow. Unexpected. Wonderful gift. You guys are so nice. Thank you again, Show. Oh, yeah, Eminem. So this is the random forest. And Parth. Hey, Parth. Do you use class weight balance often? I don't know. Hey, Sum. Good to see you. Thank you for clicking the hi button. Good to have you here. Happy Monday. Introduction to machine learning, random forest classifier. That's what we're currently working on. We're going to use scikit-learn, and we're rewriting all of our functions. We went from the other day to having a linear regression, and it turns out that can only... Hey, Mark Lemon, good to see you. Welcome on in. Happy Monday. Good to have you here. Yo, Eminem with the gold coin. Thank you so much. You're so nice to me, you guys. Thank you. The gold coin right there. Wow, check that out. Thank you. Thank you very much, Eminem. Oh, you guys are so nice. You're so nice to me. All right, thank you so much. Love to see those doing some production in there. Yep. Thank you so much, Sam. Appreciate it. That's very nice for you to say. JM, how's it going? Good to see you. Raj, hey, what's up, man? Love from India. Good to have you here. Hello from the United States. We're over here in Seattle, Washington. Good to have you here. We're currently doing a random forest classifier introduction to machine learning because it was a requested thing that we do. So we're building it from Gloomy. Gloomy said, hey, we need to do this. I said, okay, we'll do it. This is the plan for today. All right, so we've got our, would you survive the Titanic? So this is what we're going to do. We're going to figure out if we are going to survive the Titanic or not. We've got all of our data. We've got all our features. Save, make sure we don't have any more errors now. We're good to go. Still have errors. All right, survived. I need to spell that properly. That's not how you spell survived. Survived. Here we go. Let's do this. Here we go. Survived. And we don't have this data, right? Did I not return? I must not have. Here we go. So let's do this. Return. All right, let's try that. Okay, that's what I'm looking for right there. Perfect. That data looks good to me. Yo, with a clutch. What does that even look like? It just says clutch. Okay. I was like, what is it going to look like? Yo, Eminem, thank you very much. My gratitudes to you. Good to have you here, Eminem. You make me smile. It's a complete live machine learning course. Yo, Raj, yes, what's up, man? So this is, yes, we did do a course here. I'll show you all the materials that we have been doing so far. Here's the coverage. We did creating tensors, using tensors with math, so how you can combine the tensors together, indexing and slicing the tensors, right? Then aggregating, summing, a little bit of linear algebra with the solver and the dot product. We built a linear regression model from scratch, and today, we're doing lesson 8, lesson 08, which is, we're doing a random forest classifier. That's what we're doing today. Random forest classifier. Yo, Theo, how's it going? And GCA, hey! Failed to fill your years required. You have been given a year? Oh, backlog, that sounds like a lot. Yo, GCA, are you okay? Hopefully you'll get a job because, by December. Oh, yeah, that would be awesome. That would be awesome. You should do it. Get it, yeah. I have a lot of program and app ideas that would generate a lot of income. But, Theo, you're the best at designing them and not at coding them. Hey, good news. Your code can be written automatically now. Yeah, it can. What we're doing right now, live on stream, writing code by hand, you don't need to do that anymore. The AI can do it for you. It can do it for you. Would you be interested in hiring somebody like that? From my perspective, I go with what the team is asking for. So the team says we need this expert on our team, and we'll say, okay, we'll open the rec, or we won't open the rec. One or the others. The role, basically. Can we visualize one of the decision trees from the forest? Sure, I think we can. I've not done it before, but let's add it to our list here. If we have time. So random forest visualize. All right, right there. You have seen the GitHub with all the ML lessons. Amazing. Oh, nice, Eminem. Yeah, this is what we've been working on. Yo, Eminem with the thumbs up. Thank you very much. My gratitudes to you. That's so nice. Thumbs up, you guys. Right? Wait, this is the right way. Yeah, there we go. Thumbs up. There you go, Eminem. Thank you. You have used cursor a lot. Programs to complicated for most AI to hold the context. Yeah, so one of the problems is you do have to maintain code quality still. You kind of do. You still do. It's got to be quality control. You can't have too much code. Yep, so this is we're turning this linear regression, which we wrote yesterday, into a random forest calculator or a classifier. So that's what we're doing right now. Random forest. We're using some scikit-learn here because it's a lot easier. And then we're going to try it out. We're going to see what happens. So we've got our predict function. Oh, thank you for the hearts, you guys. Appreciate it. Yeah, thanks for adding on the list. Absolutely, absolutely. Are you aware of open opportunities for a remote machine learning AI? Yes, Raj, we did have one. We used to have one, but it got filled. You're late. So you scroll down to careers. Here, thank you for the hearts, you guys. And it was on our job board here. It was right here. We had it. Right now, the only left role that we have is a Rust engineer. We're looking for a Rust engineer. Core systems Rust engineer. So that's the last role. And if you want, I'll put this on our Discord server, and just in case you're interested. Link share. There you go. Available to you. Okay. So here is our training data. These are features, right? Does that look good? That range looks a little... I need to see if I can divide that a little bit more. Here, so let's do more. We're gonna do a little bit of data cleaning here. This is a smidge of data cleaning. Here we go, 100. There we go, CL 100. Now let's look at our range here. Let's see, oh, okay, so yes. The answer is we've got a good range. That's a good range. Yeah, because it can go a little bit above 1, but you don't want it to go too high. Oh, see, here's another one, right here. Okay. Looks good. Okay, we're good. 6, 7. Hey, how's it going there, Peglet, good to see ya. Welcome on back. So, thanks. You're welcome, Raj. Absolutely. Okay. So let me see. I believe our data looks good now. So now we need to do our prediction function. So let's see here. How do we use this? See, do we call this predict? We do. So we have a fit and we have a predict. Fit is going to do the training, right? And predict is going to give us the ability to pass in a batch and get the outputs in a single flow rather than doing epochs and looping over it. You're back? Well, aren't you? Wait, are you? Let me check. Hold on. Let's find out. Wait, don't go anywhere. Stay right there. Hold on. Channel activity. 1 second. Let me see. I'm looking it up. It's spinning. See? Oh, wait, I'm wrong. This is your first time here. You've never been here before. You joined YouTube 3 years ago, though. That's as far as I know. Yo, well, it's good to meet you. Thank you for joining in. We're doing machine learning today. All right. Which feature do you expect to be the most important? Age and, well, these two. I think these two are going to be the most important. I think fair is going to be barely important. I think these will be the most important. Remember the movie? Women and Children First. Women and children first. So I think those are going to be the most important. Yeah, LO, I thought. Yeah, you were right. Yeah. Rox, I thought stream was over for today. Oh, Rox! We did a second stream today because we did our first stream today with Marcus. And technically, Marcus was presenting the whole time. So we could do a second. We could do a stream. Can we connect on LinkedIn? Sure. You're not aware of anything doing, but it looks cool. Thank you, Paglet. You know what? Oh, Garcia Amir. Good to see you, Garcia. Women and children first, for sure. Right? Right? Yeah, okay, so let's see here. LinkedIn. So thank you guys for joining. My name is Stephen Blum, CTO at PubNub, co-founder with Todd Green. We raised 134 million. We have over 1 billion devices on my network. They're devices that connect and communicate. Thank you for the reactions. Know me first, eh? I know, right? Right? I know. It's like, I don't want to be in the ocean. I want to be in the boat. I want to be in the boat, not the water. I want to be in the boat. So here, I'll put this in our Discord channel, you guys, if you're interested in joining. Let's throw this over here to our Discord. So go into our link share, and I'll paste it here. And if you're interested, you can click the link and connect. 134 million, what? Yeah, that is money that we raised and used it to expand our technology footprint, and to also connect with prospects and customers. So it's like sales and marketing, and engineering is what that is. Yeah, right? I know, Paglet. Crazy, right? Oh, Rox, it's 1 a.m. All right, thank you for saying hi, Rox, even for a bit. Okay. Bro, it's Mark Zuckerberg. No, Zuckerberg is like, orders of magnitude. Just a smidgen of order of magnitude. Just sent you a connection? All right, let's find out. I'm going to open a new window and go to LinkedIn. I won't dox you, okay? I won't dox you. All right, so let's go to here. And you said Raj. How old are you, by the way? I'm in my 40s. I won't give you the exact date because that is a doxing thing, but I am in my 40s. All right, so give me your first name. Give me your first name so I can find you. Is it Amen or Anshuman? 43. Oh, nice. Hey, LT Mods, good to see ya. Welcome on in. Good to have you here. He is not Mark, he is better. Whoa, hey, very nice. Thank you. Amen. Okay. Accept. All right. There we go. Message. Okay, I'm going to send you a message. Here we go. See if that works. It's loading. It's loading. All right, message. Italy. Oh, I probably shouldn't have said that. I didn't mean to say that. Hi. Hello from YouTube. All right. Send the message. There you go. So now you know it's legit. All right. Anshuman it is. Oh, Anshuman. Oh, it is. Okay. Well, there's another. All right. So I'll also do Anshuman. Here we go. We'll grab Anshuman as well. All right, you guys, we're doing LinkedIn connections now. Accept. Here we go. I'm going to send you a message as well. 1 second. Here we go. Hello. Thank you for connecting. All right. Okay. We did it. We're connected now. Check it out. Hey, how's it going there, Nishan? Hey, Nishan. Good to see you. Nishan Cricket. Are you into the Indian sport cricket? Hey, this is Nishant from India. Yo, Nishant! Thank you for having me here. Welcome on in. Can you send a message to me? It'll be another. Sure. Yes, at user. Yes. If you gotta let me know who you are though on LinkedIn. You gotta let me know. Okay, so thank you guys. Oh, yo, nice. Okay. So 1 second. Theo's like, would you love to connect with you too, Steven? Derek, oh, is my name? I'm following you. Oh, Derek, yes, absolutely. Oh, you guys were, all right, let me see here. Network, all right. Let me see if I can find you. I see Parth. I will accept Parth. 1 second. You also said Derek. Can I do a search? Derek. Was that a long time ago? I might have to find you. I might have to find you again. Send me Oh, let's see here. What's that? Let me check. I'll see if I can find you. User. Okay. All right. I'll try it. My name is. There you go. See if I can connect with you as well. We're looking for you on LinkedIn here, you guys. All right. Well, there's quite a few. Engineer. Okay. I'll connect. There we go. Add a note. Hello from YouTube. All right. There we go. Excellent. Here we go. All right. Oh, darn. Let's see. I don't know. Hello from YouTube. Exclamation point. Okay. We did it. User, we're connected now, maybe. Oh, Derek. All right. Good. Okay. Thank you. I'll grab that real quick. Okay. We're loading that up. Okay. There's several. Wait, there's more than one Derek Alderman. There's more than one. I can't tell which one would you be. Texas or Tennessee? Knoxville, maybe? Hey, Quick Fix, hello. Hey, Roz. Hey, good to see you, Roz. Hello. Preempt. Theo's like, Aniva Inc. Oh, okay. Let's see here. Derek. Okay, Inc. Let me see if I can find that. You said a new wave. How do you say that? We're doing good, thank you. Pending Parth. You guys, I definitely here's the best way to do it. You see here on Discord, send me a direct message or a link even in Discord somewhere. And then I can click on it. And then I can definitely find you. That way. Let me see here. Though I will get Derek going here real quick. So Derek at, let me see what company. Oh, I found you, Derek. I found you. Okay, I'm connecting with you now. Here we go. Connect. Here we go. Hello from YouTube. All right. Derek, we're connected now. All right. We're both in America, you guys. How are you, bro? Been busy? All right, the last attack. Yeah, good to have you here. Thank you for saying hi. Welcome on back. All right, Parth Patankar. Parth Patankar. Would you? There's too many. Let's see. All right, you guys. I'm having fun connecting with you. I am. There's just woohoo! I'm excited. Yeah, we did it. System strategist, we found you right there. All right. So if I missed any of you, if I missed anyone, either send me a message in Discord, or just ping me again on chat and say, hey, you missed me. You missed me. Where's my follow? Where's my connection on LinkedIn? Right? Let me know. We're gonna go back to our ping. Hey, Sergio, ping pong. Here we go. Pong. This was in one of my early career. I had an engineering manager who would always use the word ping, and then I would always reply pong. I'll always ping pong. It's like, hey, are you there? Yes, I am. Yes, I'm here. Yes, I am. All right, let's get back to our coding, you guys. So I believe all of our data looks good. We've got our data in the right shape. We're ready for a random forest classifier. All right, let's take a look at this here real quick, you guys. Let's make our way. Let's make our way and make it good. So we're happy with this, I believe. Now we need to do a predict and a train function. Yeah, Sergio. So let's see here. Our predict, we need to do a model.predict. So we've got our inputs. We're gonna say return self.model.predict inputs. Inputs, I think, right? Yes, I think so. I think that does the trick. Maybe. We'll have to find out. We'll find out. We'll see if that's it right there. Also, I want to make sure that our gender is going to be a float here. We can make it that a float. Age, max age, and then we could do a float on this as well, right? We could do a float. We do an MP array. Make it a float. What do you think of... Oh, hey, let's take it out. Let's take a look. Oh, right. Yeah, you did it. You built it. So here's your whisper chat. How do I send a message back to you? How do I respond? Yo, Cyber Potato, welcome on in. Happy Monday, good to see ya. What's good? What are we making? We are building the next part of our machine learning course that was requested. Lesson 8, random forest classifier. Random forest classifier, you guys. And we are partially making our way. We adjusted our input data. We created our scikit-learn randomizer model. So, I mean, obviously we could write one from scratch, right? Which is probably, but you know what? Random forest classifier, I think we could use scikit-learn. We'll use scikit-learn. We're going to use a little library to do it for us today because there's a lot to do. Thank you for the hundreds, you guys. Appreciate it. Appreciate you guys. Very nice, making me feel good. Okay. I was wondering how we're going to do this. Look at that right there. Look at that. Doesn't that look simple? Hey, I like that one right there. This is one of the nice functions right here. I love it. Very satisfying. All right, so now, simple. Yeah, right, exactly. Exactly, Krish. It is a simple, and that is my favorite. I love it. I like keeping things simple. It's important. It's important because that means you can change it if you need to, and you can rely on it because it's simple. And if it fails, you'll be like, oh, I can fix that. That's not a problem. Makes life happy, right? So this is happiness. You don't know? It is. It's simple. It's right here. I mean, it's like a single line of code. Okay. So now that we did that, I would like to see what happens if we try to predict it. Does the random forest classifier, my question is, if you try to run a prediction through it, will it fail? Wait, you're live? I am. Flip with Kyle, yes. Kyle, we're live, yeah. A little bit late in the day. Because I wanted to get this random forest classifier in here. And we are going to do this. We're going to make it look good here. So let's go like here. Okay. Close that. And there we go. Okay. Okay. If you hear a phone ringing, don't worry. You're writing a white paper. Whoa, no way! That's cool. I like that. I like white papers. I used to not like them. Why not programming in C? Oh, hey! See, Gurpreet. See your name right there? Gurpreet? C, we've done C in the past. We've definitely done C in the past. So do this, yeah, let's do this. So you go like this. Stephen Blum, YouTube, C basics. So you see, we've done this before in the past. We've got a lot of C basics here. We're doing it in Python because we're using scikit-learn today. We're doing scikit-learn. We're doing a random forest classifier. Right there. That is in a series. We're currently on lesson 8. And this will be the last lesson for a little while. We might jump back. We might jump back and do more lessons. White paper, pitch deck, customer-facing docs, modular Figma components. That sounds like a lot of work. Sounds like you're busy. See now is better to learn data structures. Yeah, because it's close to the machine as possible before going into assembly and devolving into assembly. That's why C is fantastic, because it's really great to learn a lot of the, fundamentals of computer science. So it lets you create data structures and algorithms, right? DSAs, very easily. You absolutely love Python? Me too, Theo! And started with C++ Python. To me, always wins. Yes, anyway, it wins so much easier. It's so great. I love it too. I love it. Figma, you don't like Figma, Garcia? Send to you? Okay. Here we go. All right. Hello. Quick fix. Can only reply once. Okay, got it. Send. Did it work? All right, done. Message saved. Keep this as a private tracking link. Oh, one time. Got it. Here we go. All right. So then I can see a response. Status received, not replied yet. All right. Building applications over there. Okay. So where do we want to go from here? Let's see. let's build our train function. Probably, well, yeah, we did our predict function. Now I'm curious if we could actually use it. Will it be possible to use, or is it going to be a problem? Here, let's try it. Here we go. Okay. If you hear the phone ringing, don't worry. That's just spam calling. Probably. Try this. No error or error. Okay, so it didn't like that. Object has no attribute predictions. Okay, we can fix that. So let's see here. Where's this at? Here we go. We're going to call it predict. So this is what we did wrong here. Here we go. Reload. Okay. Hold on. And now we messed something up. Predict inputs. Instance is not fitted yet. See, I was wondering you have to call fit first. Okay. Fine. We'll do fit first. So we've got we're going to train it here. Return. And we're going to train. All right. So we probably can't specify epochs. I don't believe, right? I don't think so. I'm pretty sure we can't. Although we'll find out. We're going to find out. Let's go to our docs here really quick. We're going to our docs here, you guys. A little bit quick here. Here's our fit function. Oh, that's easy. Okay, sure. Can we say, let's see if we can find fit here. Fit. Here we go. Let's see if we can find it. Here's the actual fit function. There we go. Click on that. All right. Yep, getting lots of spam calls, you guys. DM to Discord. Check once. You're free, Steven. Let's do it. Check the linking in and tracking. All right, we'll check. So is it this one? You replied. Received loud and clear. All right, it works. Good job. Very nice. Very nice. Let's check out Discord, yeah? Okay. I'm going to hide this over here for a second so we don't dox anyone. Okay. Here we go. Let me see. Oh, I think... let me see if I found you. All right, so you said... Is it Here, I'll do this one. Okay, I'm guessing. I've got multiple pending things. Nice! All right, here, we're going to connect now. We're connecting. Whoa. Okay, let's see here. Yeah. Okay. Connect. All right, add a note. Hello from YouTube. All right. Send. Success. All right, there we go. We did it. We're connected now. All right. Looking good there. So you can run that. Not problems. Looks good. We're on the right track, you guys. How's it going there, Panda Sauce Man? Have you ever used a Scratch? Wait, what's Scratch? For learning data science? I have not. Let's find out what that is, you guys. Google Strata Scratch. What is this? Not familiar. Master coding for data science. Let's zoom in. There, you guys. Data science interview platform that has over 1,000 real interview questions. Woo! I like that. That sounds like a fun game right there, doesn't it? He's a real good doxer. So I know. I know. You didn't see anything. You saw nothing. I need 2 phones. Yeah, I do. I actually have 2 phones. Scratch.mit.edu. Scratch.mit.edu. Oh, right. The Scratch programming language. Of course. I know what that is. Start creating. Yeah, there's a drag and drop. Drag and drop all the things. Glue it together. And then you can set the values. Right? Very big degree. Leave page. It's like leak code for data science. Nice. Panda Sauce Man. Thank you. This is pretty great. Check your account on Discord. Where, wait, what do you mean? Okay. Let's get back to it, you guys. If there's anything you want me to check on Discord, you guys, let me know. If there's any chat messages I missed, let me know. I love how Stephen Minds works. Very impressive multi-threading processing. Oh, thank you. Theo, that's very nice. On Scratch. Oh, I didn't know you could do that. Scratch.mit. Is there a way to search? You said KBPAWER. Whoa, you've been busy. You've been busy. And you can't vibe code this, you guys. You can't vibe code this. Wow. Well, I mean, I guess you could ask ChatGPT to like tell you what to do. Minecraft clicker. Welcome to Minecraft clicker. It's like a cookie clicker. Yeah, it's an idle. It's an idle game, you guys. Wow, no way. Yes. This right here, you guys. This. You got your latest one in the back end? Nice. See how many? See how? Can I click it like so fast that that's like the maximum I can click it. I hit my max click. Not enough cash? Okay. Not enough cash. I like clicking it though. It makes me happy. All right. Okay. Anyway. Quick fix. Nice. Good job. Raj, how about can you share some thoughts on my live AI machine learning project? Sure. Send the link in the Discord. Send the link in Discord, you guys. All right. Definitely, Raj. We will take a look. So let's go back to our docs here. We had a fit operator. Here it is. Sample weight. We don't need to worry about that. X, array-like sparse matrix. The shape is samples. So it's a batch. Good. We're already there. We're already in the right shape. Now we just got to make sure that our batch is correct. We got to make sure our batch is correct, you guys. Train. Here we go. Where are we at here? Let's look at this. Okay. All right. So our features are correct. Those are correct features. Now our targets, do they need to be? Do you guys know if it needs to be a float? Do you know if it needs to be a float? I actually don't know. I think only the inputs need to be. Although I don't know for sure. I don't know. Let me look at some notes over here. Features fit, targets. Okay. All right. Let's see here. Let's see if we can make this work. All right, here we go. Train. We will do self.model.fit. Features, targets. I think that should do the trick. I'm pretty sure. Is there anything else we need to do? I think that's it. I think literally that's it. I think this is it right here. Nothing else. Although I might need to change the targets. What do you got over there, quick fix? Whoop, whoa. Gotta be careful with that. This project uses cloud data feature. Okay. Verifier identity. I'm looking at it in another screen right now. What does it do? This is a demo for a minimum. If you encounter anything, say, okay. I don't know what it's doing. I don't know what it's doing. It's just sitting there. I tried it. Okay. You need to verify a Scratch account though? Oh, got it. Yo, Garcia. Hey, thank you for the F10. Well, the F. Garcia, my gratitude's to you. Whoa. Thank you very much. Garcia, you're very nice. You're very nice, Garcia. Thank you. Well, here's your, here, I'll press F for you. Can I press F? There you go. F on the keyboard, you guys. Right there. Gotta go, Steven. Love today's stream. Till tomorrow. All right, till now. Would continue later. In my free time. Adios. All right, Parth. Thank you for hanging out with us. We're just gonna continue with this random forest model here. See if we can make it work. Let's see if we can make it work, you guys. I think we can. I think we have the opportunity to do it. Let's see here. Let's try it out. Let's see if it works. All right, train. Do we get a return? All right, so return here. See if that fits. No errors? No errors? Okay, so we do have an error here. Sort of. It's a warning. Data conversion warning. Column vector y was passed when a 1D array was expected. Oh. So it wants this to be a vector, not a matrix. Okay, got it. It checks if you are on the banned list and if I can use cloud vars. Oh, nice, okay. Features, targets, context. Yeah, so that's the part that I'm missing, is the targets need to be different. So I think we just do this. Here, dot, 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 dot. Simple, easy. Like that, yeah? A little bit like that. I think, probably. Works good. And there we go. All right. That was super easy. Okay, so we've basically completed the model. Now all we have to do is measure how good it is. And then we're going to create a range. And I'm going to show you guys on the screen, would you survive Titanic? That's it. Would you survive Titanic? May I share here? I don't have Discord. Would you mind to check? The thing is, you can't type a real link unless you're a mod. And we've got a lot of mods. Thank you for the party poppers, you guys. So Raj, absolutely, I will 100% take time to take a look at it live on stream right now. We'll do it right now. We will. However, we got to figure out a way to get me the link. What you could do is send something that looks like a link and exclude like the HTTP and other things like that. That might work. I don't know if Google will block it. Google usually blocks it. They're pretty good at that. But if you can like describe to me a way to get to it, I'll try my best. All right. Let's keep on going here, you guys. Okay, let me try. All right, sounds good. So we've succeeded here at our random forest. We're very happy about it. We're very happy. Now what we need to do is test it. Let's see if we can do a test here. All right. So we need to get our inputs. We'll say everyone pays like $10 maybe. Fair equals $10, right? And then we're gonna have an age. So let's see. We're gonna answer this question. If you, yes, you were on Titanic, the Titanic. Let's try that. Yes. On the Titanic, would you survive? Would you survive? All right. So we're going to create a range. Let's do this. Let's do this. So we'll say, we'll create a, let's do something like this, something really simple. So we'll do our data, our features. So for, let's see here, age in range. And we'll say like, how do we want to do this? Can we do a step? So we'll go 0, 60, 5, right? I think that should be good. Okay. And then we will say age. What does it need to be? What is the feature list here? It is age, gender, and fairs. And then we will say age, say gender. I suppose we could do a, we'll just say 1. Well, here's the problem. That might not be the trick because it's women and children, right? So gender female is 1, otherwise it's -1. So we'll do both. We'll do both. Male equals -1, female equals +1, right? I think that's the answer. So we'll create 2 ranges. So that way we can see both sides of the coin. How many lifeboats are there? I don't remember. It's however many there were. Google how many lifeboats on the Titanic. Oh, we can't do a question mark. Here we go. Okay. 20 lifeboats. 14 standard wooden lifeboats, each holding 65 people. 4 enlarged collapsible canvas boats holding 47 people each. It seems like they should have had these collapsible canvas boats mostly, right? So these, because if they were collapsible, you could have more of them. Why didn't they do that? Which error types are we need to use it for testing our large language model? Which error types? What do you mean? Yo, hey, how's it going there? Jose? Does it say Jose? Thank you. Claudio Vargas, thank you for subscribing. You joined the right channel for software engineering. We're currently building a random forest classifier. Well, we're using one is what we're doing. We're using one with scikit-learn. We are taking the lesson from yesterday and we are testing and our linear regression model that we wrote from scratch, and we're going to be using it in a classifier that is the random forest kind. Like absolute error or something like that. Oh, yeah. Okay. Yes. Okay. So when you're doing a large language model training, you're going to do negative log likelihood loss, right? And that is a cross entropy, right? Cross entropy loss, right? Something like that. That is going to give you the most likely next token out of a set of tokens. So all of your output data, right? All of your output data. That's the trick. That is absolutely the trick. Oh, hey. All right, another Scratch project there. Okay. Who is the best YouTuber? Click me. All right. Here we go. We're going to find out what the answer is. I don't know who the answer is. Who is the best YouTuber? Click me. Here we go, you guys. It's Stephen Blum. Hey, I wonder who that is. Thank you, Quick Fix. That was nice. Oh, let's do it again. We'll click it again. Hey, it's me. I wonder who it is. Very nice. Thank you. That's very nice. I was not expecting that. Let's close some of those windows there. Hey, TSD, good to see you, bro. I'm a beginner entering a uni. Give me some advice and roadmap for coding and programming. So you're going to want, let's type this out on the screen. All right. So this is what the industry uses. If you want a job in industry, we got Python, which is what we're using right now. We've got JavaScript and TypeScript, right? You're going to want SQL. There's very little industry jobs for C and C++. There's not very much there, right? So these are languages that you don't need to know heavily unless you're going into a very specific role that you know you're planning to do. So these are important to industry languages right here. And then also HTML and CSS are good to generally know. These are good to know because they're web tech, right? Web tech. Hey, you're back. You're learning C. It was basic. Hey, all right, Hassan. Good to hear. C is a waste. Yeah, so C is good if you want to learn the fundamentals of computer science because it's so close to the metal, very close to machine code without you having to devolve into assembly. It gives you all the ideas. Recheck sounds good. This one here. Whoops. Here, rechecking. All right, here we go, you guys. Quick fix. I knew it. I knew it. Who's the best programmer? I mean, who's the best streamer? My favorite programming language was assembly. No way, Garcia, really? No way. So these are the important ones to learn. If you're going to learn those, there you go. Steve is a genius. Wow, thank you, Sergio. Appreciate it. You haven't touched Python. What to do now? Well, try it out. All you got to do is start. Open up your terminal window and type in Python. Like this. Python. There you go. A equals 1. A plus 1 is 2. There you go. Start off simple. Start off simple, you guys. Keeping it easy and clean. Easy and clean, you guys. Let's see here. Let me know if I missed your message. Just let me know, you guys. C++ middle level language, assembly is low level language. Yes. Python, Java are high level languages. Yes, exactly. So you also don't need Java either. So these are languages, unlikely languages. So you don't ever need these. These are necessary. These are common languages here. Common languages in industry. Right here. You want those. These are the good ones. These are the good ones right there. C seems easy to you? Yeah, Hassan, exactly. C is pretty straightforward once you get it. Boy, genius. Sergio, thank you. You're going to add randomness. You're going to okay. Oh, so it could be RNG. Yeah, do it. That sounds great. Once you start learning programming language, it makes it so much easier to learn just about any other language there is because they all follow very similar rules. Yes, flow control, variable assignment, expressions, object-oriented modules. Right? They're all this list comprehension. Theo is light. You're absolutely right. 100%. Java is very stable and strong document. So that's why you prefer it from companies? Yeah, so if you're gonna go into, there's a chance that you might want Java. There's a chance, but you never know. Yo, hey, Wave of Consciousness. Thank you for the silver star, appreciate it. Thank you very much. Gateway 2 program. It is a gateway, it is C#, there you go. See, C# is even up there. Like I would put C# up here. Because this is a heavy Microsoft world. Hey Raj, thanks for saying hi. Hassan, object-oriented programming, you know it. OOP, you guys, OOP. There you go, the op. Not to be confused with is not, you don't want the ooms, but you do want the OOPs. Sometimes you want OOP. Sometimes you do. Nice tat. What you think about Rust? See, I would put Rust on here as well, on this list next to C++, or next to C#, because I use it at my company. You guys, if you're new here, and you guys, a lot of you are, you know, OOP's goated, bro. Is it? It's pretty good. My name is Stephen Blum, co-founder at PubNub. We use a lot of Rust. We've rewritten our entire stack in Rust, and we've seen phenomenal benefits. Way faster. We've entered into the microsecond level of latency, which is fantastic. It's one of my favorite things. I love it. It makes me so proud. Big project, we think we need to use type hints in Python. Oh, it's good to do type annotations. As you can see here, I'm not using any type annotations. I just choose not to do it. Can you define a short syntax for Rust? Yes, see, that would be great, Hassan, if we could have a simple version of Rust. That would be really nice. What you can do, though, is you can still be a Rust programmer and avoid a lot of the complexities. Avoid, like, lifetimes. You don't want to deal with those. It's not necessary. If you want to deal with something, just put a box around it and you're good, right? So you can load data onto the heap, leave it on the heap, it's there, and when the program is done, it's done. So you could use boxes. That's fine. Do boxes. You don't need to do arc as much. If you can avoid mutexes as well, you don't want any locking in your program. If you need to do it, okay. 'Cause I had to do it before because I was doing something a certain way. You can build everything asynchronous, which is much better. Much better. Can you write small code? You can write pretty good code. It's not that verbose. It's pretty verbose. Hey, Redless Saber, good to see ya. Thanks for saying hi. Welcome on back. Big project, think we need to use a daily define. Oh, can you see here? The problem with C is that if there is no try block. Oh, right. There's no try catch. There's not. I forgot that. In C, there's not. You just have to do your best, right? You got to do your best. Let's see. Modern World Company uses heavily on Rust, Go, and Python. There you go. Oh, Go is another good one. Yeah, Golang. Thank you for reminding me. These are good ones here. These are the common languages you want. I agree with you on that. Highly paid, go earn these diverse job roles. Yes. How much time would it take to learn machine learning? Start from bottom rock without math background. So I did that mostly. I had some of the math background, but not really. Like just a smidgen of the math background. And it took me probably a couple weeks. You can easily take care of it in a couple weeks. Easily in a couple weeks. No problem. 2 weeks, easy. 2 weeks, easy, you guys. Okay. All right. Ooh, okay. All right. Okay. My goodness. Let's keep going. Let's get our... What keyboard do you use? Hey, I was going there. Danif, this is just a Mac keyboard. I don't know if you can see that very well. Ordinary keyboard. Very basic keyboard. You found the solution? Raj? All right, good to hear it. All right, so we're going to get rid of this. Clean up our screen here. Why Python everywhere? Whole course was low language and the middle language oriented. Oh, Hassan, Python is everywhere because you can use it for data science. You can use it for machine learning, AI, which is, a big deal these days, right? Big deal these days. You can also use it for web servers and microservices. And it's really easy to use. It's really easy to read. Basic, the best keyboard. Yeah. Are you programming games? I've built games before. I have. I used OpenGL and DirectX. That was back in the day before there were really good frameworks. So you always had to build your own framework. Always had to build your own framework. Can you give some tea on how companies interview for a backend role? Yeah, so first off, the most important thing is your collaboration and your communication style. When you're working with the interviewer, they're going to ask you questions, and really, they would want you to give you general positive and true answers. It's less about the correct answer and more about how you communicate and collaborate with them, right? That's really the critical part. Are you able to work with them together on a problem and solve the problem together? That is the valuable thing. That's the most valuable thing. So it's really about that. It's really more about that. Rather than like tech questions like, oh, can you build me a hash map? Okay, what? All right, here we go, let's do it. So there's a bunch of buckets here, and then you decide on how you're going to, encode whatever input data you have here into a number, and then you're going to mod the number by the number of buckets. And then you know where your bucket placement is. And then you can have hash collisions. If you have a few buckets, you'll have a high amount of hash collisions, which is fine. You just do comparisons with those those buckets that have the collisions. So then it just slows down after a while. And then you could do bucket resizing, right? So that's like the kind of thing that you could also talk about. Will AI replace programmers? Will AI replace programming manual? Yes, it already has. It already has. As far as I know. Bro, what's a hash map? Oh, it's a data structure. It's a data structure. What? Google, what is a hash map? Comp sci. Here. All right. So a data structure. Whoa, look at that. We're right on target. Stores information about key value pairs. It's a way for data storage and retrieval that is log n of O, right? So it is it's like as fast as you can get retrieval. It's like a really fast retrieval. Let's see. Yep, O of 1. Sorry, O of 1 is what I meant. Constant time. Constant time. There we go. So in companies, the important thing is collaboration. Yes, Hassan, absolutely. You got it. You got it, Hassan. In order to get a job in tech companies, we'll also need other skills besides programming. Probably now these days, because you're going to need to know how to code with AI agents, because the AI agents can code very quickly for you. And that wasn't necessarily the bottleneck, because now the new bottleneck is decision making. And so as an engineer, you need to decide what you're going to implement. That's what it is. Hashmap equal dictionary. Yes, exactly. Yes. Yes, you get it. Gold star. Here we go. Gold star. At Garcia. You get gold star. Good job. Will AI bubble burst sooner or later? I would say AI is here to stay. We're so used to it now and we're very dependent on it. We're going to see certain companies maybe come and go. The cost is very high because compute and the amount of our algorithms that can leverage the compute needs to evolve. And it will over time. So we'll see better hardware, better algorithms, and competition will drive costs down and put pressure on these big studios. I missed your message, Raj. Oh, what'd you say? Raj. I found a solution. Raj said, you missed my message. Oh, Raj, you got YouTube fixed you. They're like, nope, you can't do it. YouTube was like, nope. Here we go. 1 second. Here we go. Is this it here? All right. You missed my message. I found the solution. Probably what happened is YouTube blocked your message is what happened. YouTube blocked your message. That's what happened. Sorry about that. You got my sub. I like your content. Yo, Danif, thank you very much. Appreciate it. You joined the right channel for software engineering. Good to have you here. We are currently working on Introduction to Machine Learning with Random Forest Classifier, and I will finish this before end of stream. And because I know we're basically there. We've done it. Thank you for the hearts, you guys. We got the fit, right? The training. We got the training. We've got the prediction ready, and we've got all the data prepared and ready for us through Scale. Now all we have to do is test the data. And we're going to find out the ultimate answer. Will you survive on the Titanic if you were there? You'll survive. Thank you for the hearts, you guys. Appreciate it. Let's see. Mine too. You really need more subs, bro. Thank you, TSD. Appreciate you. Did you take a look at Herd? Yeah, I did not take a look at it, Erdem. I have not. Let's take a look at Herder right now. It's called Herder. All right, let's just take a quick look at it. My YouTube recognized unusual word or specialized character. Did it really? All right, let's look at Herder. Thank you for the hearts, you guys. Google HERDR Herder app. Let's see how to do that, right? Google. There we go. Herder. Let's see. Let's find out, you guys. Let's find out. One terminal for the whole herd. We're just going to look at it. We're just going to look at it. Claude code. Yeah, it looks like Tmux. It looks like Tmux. Yeah, this is what I do in Tmux all day long, you guys. It looks very pretty. So it's like for your coding agent, you can run multiple coding agents and have something on the side. Yeah, this is like basically Tmux. You're right. You're right. Look at that. Okay. Very nice. Bring your existing agent to the herd. Any agent. Whoa, look at all these agents, you guys. Hermes is an agent? Yeah, I guess it is. And think of that. I always think of like Claude Code and Codex. Thank you for the hearts, you guys. Appreciate you. All right. Let's see. Tmux for AI agents. Yeah. All right. In my opinion. Oh, Red the Saber. AI won't fully replace programming. Right. We still have engineers. Engineers still have to make decisions. So that role is still there. Even if the AI could fully generate everything for you, you still need someone to be there to figure out what we actually want to do. So you still have that role. Can't really replace us, especially in games, because most of the gamers are against AI. They are, aren't they? Can we make a virus any language? Yes, Hassan. Yes, you can. What AI use standard with n8n? You can use any of them. Like you could use OpenAI. You can use Google's Gemini. You could do Claude, Anthropic. You could do OpenAI. Let's see. Any of them work, really. I would recommend Gemma 4 if you get a chance. I think that's a good one. I think that's a pretty good one. Let's see here, you guys. To excel in data structure, honestly, with routine study, how much months does it take? If you were diligent every day, you can learn it in 1 month. You could. If you were diligent, you could learn it in 1 month. But you might not be diligent, right? You might not be diligent. So it might, if you're not diligent, it might take you 2 months, right? Let's destroy AI so we don't want to compromise our jobs. Oh, I know, right? I know. It's danger zone, right? 1 second, you guys. All right. Let's see here. All right, here we go. Okay. Let's finish our random forest classifier. Let's do it. Thank you guys for the hearts. All right, back to it. Random forest classifier. Let's get going. Virus in Scratch is hard. Well, yeah, that's a good point. It's isolated, isn't it? It's like it's fully encapsulated in its own like little world over there. Let's like the stream, guys. Oh, hey, thank you, Danif. Thank you very much. Daniflix. Yo, Raj, hey, thank you for the star. Silver star, appreciate you very much, thank you. Anthropic just acquired Wolf. Wait, what? Really? Hold on. Whoa, timeout. All right, what is that? What is even Wolf? What is that? All right, Google Wolf Anthropic. See, we're learning new things. This is why I'm with you guys here. TerraWolf signed Blockbuster 20-year lease. The agreement valued approximately at 19 billion contracted value during massive surge. No way. Well, that doesn't sound like an acquisition, does it? You still need integers, but less. What is? I don't know exactly what that is. Okay. Let me find this real quick. We're just looking. All right. Good. All right. Okay. Reduce too much because of AI? Only a few senior managers, everything? Or will it create new jobs? I think it's going to create new jobs because now coding is available to everyone on the planet. Everyone's a coder. So that opens up a lot more opportunities for businesses to adopt code and custom code into their own business, right? And now you're going to have like different kinds of engineers, like agentic engineer or like coders or like, I guess AI drivers or something. They might not have traditional computer science backgrounds. They still can write code and build apps. So there's going to be more of those types of roles that are available. And it's going to create this massive footprint. Are your mods removing the message? No, they are not. Raj, if it includes anything that looks like a URL or a link, Google won't let you do it. They won't let you do it. It just won't happen. Oh, lol, what? This is how I can search from your terminal. Yeah, everything in your terminal. Exactly, Danaflix, you got it. AI will be the end in a few years because of the cost to operate. So TSD, it is increasing in cost. However, we are improving the model's capabilities and the algorithms that drive them. For example, Google just released Gemma 4, and it includes like an 8x reduction in the total compute required to predict the next token. They did a really good job, and we're coming out with new novel algorithms. So we're making advancements, and the hardware is getting faster, and the old hardware is getting cheaper. It's like, you know what I mean. You know what I mean. Anthropic. Oh, oops, sorry. Hey, Sergio, no worries. It looks like they did, but it doesn't sign block spec. They just signed a lease. It looks like it signed a lease with a 401 megawatt data center, which is a big data center, for 19 billion. Wow. Gemma 4 is very good. Create a Pi agent for your full college. Oh, nice. It processes 15,000 slides locally on a CPU in under 30 minutes. Grunkle Stanley, that is great. I didn't know that it could be that good. Did you code a program to open searches? Yes, I sure did. I mean, it's an alias. It's an alias, so, right? Let's see here. /.ZSHRC. SHRC, there we go. And here's our Google search right here. So technically, yes. Yep, right here, you guys. Right there. A little bit of Google aliasing for you. So a pulp library can be used to model the kind of mathematical problems you want to solve. Oh, nice. All right. All right, there we go. Curious if you ever used it. I have not. I have not used the pulp library. I have not used it. All right. So let's see if we can do this, you guys. So we get age, let's see, we'll say male, and then fair, like that. There we go. And this will be group 1. Then we'll have a group 2. There we go, group 2. We'll do female and group 2. I think that'll work. Survived. Let's see, group 1. Group 1 survived. Thank you for the hearts, you guys. Appreciate it. That's epic. Is it? Mac? Yes, this is a Mac. You name Darwin right here. A little bit of Darwin. Darwin on the screen, which of course you mean Mac. Google optimizing single handy. It's pretty good, TSD. It's pretty good. I like it. I do like it. The Google avatar is turning your head. Oh yeah, Theo, yeah. You saw that? Yeah. You can do it too. It's just a GIF. It's just an animated GIF. It's just an animated GIF, you guys. The project starts with Wild Grad AI in 2026. Oh yeah, 2026. Okay. Project starts with Grad AI in 2026. Raj. Okay. So is that what should I Google? Is that what you're saying? I'll try it. We'll see if that works. Okay. Check the message above. Sure. Search that on Google. Okay. We'll try it out. 000. Get rid of that. Okay. All right. We're going to try it out. Let's see where are we at here. Okay. Did that work? That didn't seem to work. Here we go. Wild. Try that. Is this it right here? No. Is that it? WildGuard AI? Age you started coding? Garcia. Me, 11. 11 with C++. C++. The Streamlit one is mine. Oh, Streamlit. Doesn't seem to be... Let me try this again. We'll try it one more time here. Let's see, where are we at? Where are we at, you guys? Where's that at here? Right around here. I'll try it again. Here. Okay. Delete wild. I said wild with guard and AI 2026. Okay, so this right here. All right, let's try that. Okay. Is this it? I can't tell. How did you get your photo there? Oh, this photo here? This is just, I assume, my Google account. Oh, well, yeah, now you see my email address. You didn't see anything. You saw nothing. You erase it from your mind. I heard about a game on Steam where you can learn programming. Oh, in a fun way. Yeah, it's called The Farmer Was Replaced. Torva told us about it. The farm was replaced. The farmer was replaced. But it's animated. Yeah. Raj, the Stratman link. Okay, let's try this. Stratman. I'm looking. WildGuard, ICLM, HBR, ICLR, Agent Wild Workshop, year, the Chain Guard. Let's see, you said the first one is mine, you're there. Okay. Here we go. We're going to the first one. Is this it? Yes, it's so good. Is it, Danaflix? I want to try it. I really do. Which IDE are you using? Me, I'm using Ghosty, Tmux, and Vim. Ghosty plus Tmux plus Vim. There you go. Not this, not that. Okay. So it's not the first link. Hold on, let's bring that back. So the second link, maybe? Try the second one. That's probably not it either. So this one. How people... No, definitely not that one. All right, you only... What about this one? Second workshop agent, wild safety security? Nope, not this. This wouldn't be it either. Your stream is awesome. Yo, son, thank you. Appreciate it. Remove and the search. Okay. Try that real quick. All right, this is the last time. If it doesn't work, we're not going to go any further. We're going to give up because I do have to get going here. Do you use MacBook or Mac Mini? MacBook. Danaflix. At Danaflix. MacBook. Got a MacBook here. And remove with. All right. This is the last one. This is literally the last one. Looks like all the same. Oh, Streamlit. Here we go. All right. If this isn't it. Oh, why hackers love Linux? Oh, because it's so fast, clean, and you know what's running on the system. It's not bloated by a bunch of corporateware. Is this it here? Raj, did we do it? Did we finally make it? Yes, 100%. All right. That took a little while. We did it. Hey, Raj, we did it. All right. So beyond observation into preservation. WildGuard AI abandons reactive conservations. We merge strictly deterministic machine learning, a whole bunch of historical baselines, upcoming data integrity to give wildlife authorities absolute predictive supremacy. Okay. All right. Yeah, I love Linux. I use Linux all the time. We did it. We did it, Raj. Grunkle Stanley, if you try to read and reply all the comments, your learning is not going to happen. I know, you can imagine, you can ignore off-topic and interesting comments. I'll do my best. I'll do my best, Grunkle Stanley. I'll do my best. Time series forecasting. I'm clicking on it. It didn't do anything. It didn't do anything. Okay, so this is just basically a portfolio. Nice. All right, so this is like basically all the things you've done. Establishing connection. Oh, I have to, okay. I don't know what, I don't put any information in though. For inside. Looks like it was made with Cloud Code. Yeah, maybe. Let's see here. Probably. That's usually the case. Uh-oh, did I break it? Well, it's broken now. Is there return to discovery? Here we go. Okay. All right. All right. It's pretty. It's nice. It's got various things in here. All I could say is, good job. You did it. Register with any anime unpassword. All right. Let's see here. It won't type. Oh, it barely types. I see. Okay. Save. I can't see anything. So I can barely read this. I can barely read that. So that's a fail. That's a fail right there. I can't see what's going on there. Let's try that. Okay. Yeah, I tried to create an account. It didn't work. All right, so that's as far as we go. Sorry for that. Yeah, no worries. So this is a website of one of your commenters. Yeah, that was Raj's website. That was Raj's website. All right, guys. So we have to finish this up real quick. We're going to find out whether you survived or didn't survive. All right, let's find out. Group 1 survived. Group 2 survived. Here we go. Let's try this. Group 1 and Group 2. All right. Let's see if that works. Let's see if that works, yeah? Python lesson 8. There we go. Unmatched. I can figure that out. Where is this? Here we go. Clean that. Save. Run. Oh, it's working. Oh, it's working. There we go. Okay. Print Group 1. Print Group 2. Here we go. And then we're going to see what that looks like. All right. Did that... Wait, are we seeing the output? Why isn't it not printing? Did I not... Oh, I returned it here. Oh, okay. Hopefully this works. Hopefully this works. Let's try this. No crashes. No crashes. Yeah, there we go. Okay. 10, 10. Right. 0, 5. We can't do 0. We should do more. We should not do 0. We should do like, I don't know, let's say 5, for example. Okay. 5 to 60. There we go. 5 to 60. Okay. Would you survive if you were on Titanic? We're going to find out. We're going to find out, you guys. Here we go. All right. Group 1, Group 2. Which means you're male or female. What is this? This is a random forest classifier. We're getting all the data from from Titanic. All the passenger data. Look at all the passenger data here. So you know, like, their age, their gender, what fare they had, how much they paid, what their class is, and whether they survived or not. So we can take all that data and then put you on into this, your age, for example, into this model and find out whether you would have survived or not. Got it. Dark mode. Okay, understood. Let's see. There's a lot there. Trust me, the dark mode and create an account. Just a front end issue. Yeah, so I kind of ran out of time here, so I do have to finish it. I need to finish this here. I want to make sure this works. And then I have to go do some work. I got to go do work. Okay. So let's see here. Let's see real quick. Let's see. You would survive. Yes, Group 1 or Group 2. Let's find out. Here we go. Here we go. Okay, so that's the data. All right. And then we need to see if you survived or not. Here, I want this. There we go. Okay. Group 1, Group 2. Okay. All right. Now, it would be nice to be able to show, oh, wait, they're all ones. That's definitely not true. That seems like a problem to me. So that didn't work. Mostly though, it seems like, so we're missing something. What are we missing? Max depth. Do we have that? Max depth. Let's go 2. Let's go 2 on that. Number of features. We know that's 3. Okay, let's try it again. Let's try it again. 0. Oh. Okay. All right, we got it to work, and that's what we're going to call it today. That's what we're going to call it. I don't know if you can read the data on the screen, but it's very telling. It's very telling. Sergio with the rows. All right. Check if you get time. All right, sounds good. Sounds good. All right. Hey, Kyle, how's it going? You posted an image and link share. All right, do you think a good time? Yes. So we are wrapping up here. So if you guys don't know, what we just did is we answered the question, would you survive if you were on Titanic, based on your age and gender? And basically the answer is, if you were male, you would die. You would not survive. If you were female, you would. That's it. That's what we found out here. That's what we found out. That's based on the data. Doesn't matter how old you were. If in that case, you would not have made it. Why? I mean, that's just the data that we got. Because remember, women and children first. Remember, Hassan? Remember the Titanic? Women and children first. And they're, how is it as a kid? I know, well, you know what? Our data only went so far, and it said if you were a male, that's it, you're done. So it's just the most likely, right? It's the most likelihood. How'd you get the data? This is from Kaggle. Yeah, the lifeboats. Yeah, there weren't enough lifeboats. That's why, Sergio. That's why, exactly. Exactly, there were not enough lifeboats. Here's the data, right here. We got all the data from every passenger. The Titanic was an inside job. Yeah, I don't know about that. Are you still on the job? I do have to get going here, but Kyle has something for us on Discord really quick. Let's take a look. You said on link share, yeah? So let's see here. Are we on link share? Link share. All right, scroll. Is it this? What do you think about this subtitle? This, read the white paper. Nobody wants to make a listing. Point to camera and we'll handle the rest. Ooh. Ooh. This tells the story. This tells the story. It does. You did it, Kyle. You did it. Oh, what's the music right now? This is Bodega Adam McDougall. Adam McDougall, Evil Bodega. There's your answer. Okay. Hey, Steven. How's it going? Shravan. Hey, Shravan. Good to see ya. Welcome on in. How did you set the music to live? Did you use OBS to an external music to repeat the system? Yes, this is OBS. We got OBS right here, you guys. So we got our music right here. All right. Okay. Hey, Stephen Hawkins. All right. Can you look at my post on Linkshare too? Sure. Loons. If it's a long, I remember it was 14 years ago. All right. If this is too long, I can't watch it. All right. It's 1 minute. We'll watch it. This will be our outro, you guys. This will be our outro. Here we go. This will be our outro. All right. So good to have you guys here. 1 minute long. You look smart today. Yo, thank you. Appreciate it. Yeah. We don't have a hoodie on. We've got like a regular jacket. Kaggle. Wait, that means the exercise every, yeah, AI and yeah, exactly. Yeah. Grunkle Stanley. It is. Here we go, you guys. Let's watch the video. So we hooked up a clever bot to itself to watch what would happen. Okay. All right. I forgot about that. That was a while ago. 14 years ago, you guys. 14 years ago. Loons, thank you for sharing that. That was kind of funny. From India, Hearts, thank you. Thank you very much. Boy, genius. Hey, Sergio, thank you. Which country are you from? I'm from United States, Seattle, Washington, you guys. United States, Seattle, Washington over here. Steven, do you use Linux on your Mac or do you use Mac OS? I am Mac OS. That was 14 years ago. That's crazy. Whoa, that's crazy. Wow. Crazy. Yes, so I use Mac OS. I use Mac OS, you guys. Mac OS. All right, you guys, thank you so much for hanging out with me today in the afternoon. We'll be back tomorrow with our usual time stream, and we are going to start building YouTube. We're going to do a YouTube clone. I'm going to start building the server side part of it, where we load the video, and then we can serve the video. Thank you for the hearts. Sent the link in Discord. All right, sounds good, Raj. I got to head out now. Sir, what will be the next topic? Yes, Hassan. So tomorrow, we're going to start building this in our Discord right here. It's called Real-Time Group Project. We're going to do a real-time group project here. And I'll make... so Quick Fix has the GitHub repo. And we'll all contribute to the GitHub repo. That's the plan for tomorrow, you guys. I'm looking forward to it. We'll be doing more Python. Python because it's easy and clean. And then after that, I do want to go back to the Candle library. We've got so many plans for live on stream. We'll be doing more Candle. We'll be doing some Haskell. We'll be doing more assembly. We might do some more introduction stuff if you guys are interested. More intro stuff. So we're good to go. We're good to go. All right, guys. Have a good rest of your day. See you tomorrow, everybody. Thank you for joining. Bye. See you guys tomorrow.